So a space probe is launched vertically upward from the surface from a spherical planet with a radius r. If the atmospheric drag is ignored, the upward velocity v meters per second of a probe at height h, meters above the surface of the planet, is modeled by the solution of the differential equation dvdh equals negative gr squared over v r plus h all squared, comma, v equals u, where h equals 0, and show that v squared equals u squared minus this expression here. Okay, so take a look at what you have and have a little bit of a drawing. Okay, we've got a space probe launched vertically upwards from the surface of a spherical planet. You've got a planet, which is a sphere, and you've got a probe of some description, and we're launching it upward. Now, this planet has a radius of r. Now, you're ignoring atmospheric drag. They're telling us that we can assume dv dh equals negative gr squared over v r plus h all squared. And you're told that when v equals u, where h equals 0. So height h, so if the object is up here, then this is h. And so we know that at this point here, h equals 0, v equals u. So they're basically telling you that at this point here, for v equals u, h equals 0. That is the sort of initial velocity. And you want to show that v squared equals u squared minus 2gr over 1 plus r over h. Okay. Well, keep in mind when you're doing questions like this, what are constants and what aren't. So what is known? Well, r is a constant because it's just the radius of the planet, which is presumably not changing in the question. U is a constant. That's just the initial velocity, which again, presumably is not changing once you've launched it up into the air. V and h are variables, of course, because at different heights, you're going to get different h and you're going to have different velocities. So v and h are variables. And they're related to each other through the differential equation. G is a constant. Presumably your planet, once it's fixed, has a particular sort of attraction. So they didn't really explain G, which probably is not very helpful for students who don't do physics. But G here is really just, I mean, all you need to know is a constant. But if you're not comfortable with it, it might not have been very clear what G was. And G is just basically representing an acceleration due to gravity situation. And I think that covers all our letters. V, U, G, R, and H. Right. So keep in mind that all of these are constants. And now you want to find V squared equals U squared. So basically you want V squared, or V, as a function of H. That's ultimately what you're trying to do, right? Because everything else is noise. This is a constant. This is a constant. Everything is constant, right? Constant, 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 constant. They're all constants. Ultimately, you can summarize it as find V or V squared as a function of H. That's your job. Okay. So with a initial condition like this, that highly suggests that you involve integration. All right. So hopefully we've got enough space here to do it. All right. So we've got dvdh. I will probably just do this on the whiteboard just to be safe. All right. So we have dVdh equals negative g r squared over v r plus h all squared. You'll notice that the right-hand side is, well, has v and h. So you need to basically get them separated. So that means you're going to have v times dv, like you move the v across. And then you've got negative gr squared, which is a constant. So we'll just take the constant out, all over r plus h all squared. Now I'm going to treat that as negative gr squared because I don't really want to touch that, times 1 over r plus h all squared dh. So I guess what I'm basically saying here is I've moved the dh across to the right-hand side, and I've moved the v here to the left, right? So my left-hand side has become v dv, right? Move the v across, so v dv. And then I'm left with everything else, which is negative gr squared over, without the v, r plus h all squared dh. And now I can integrate both sides with respect to their respective variables. So v dv, integrating v with respect to v, is quite simple. It's just half v squared. I'll put the plus c here. I mean, I'll need to put the plus c on one side, and this side looks a bit messier, so I'll just put the plus c on the left. We need to find out what that c is anyway. And it doesn't matter which side we put it on. You only need one, right? Because constant on the left, constant on the right, move them to one side, you're left with just one different constant, so it doesn't matter. So you've got negative r squared. The integral of that is just, I mean, in case it helps, it's negative g r squared times the integral of r plus h to the power of negative 2. So we're keeping that in mind. It's going to be 1 over n plus 1, right, which is negative 1. All right, 1 over a, well, there's no a, 1 over n plus 1, ax plus b to the power of n plus 1, plus c, which we've already dealt with. So that negative will cancel out with this negative, giving us positive gr squared all over r plus h. Now, let's just multiply everything by 2. So that means I'm going to have v squared plus c equals 2gr squared over r plus h. I multiply this by 2. A constant that I haven't worked out multiplied by 2 is still a constant, so there's not really much point in writing 2c over here. It's still a constant. So I now have this thing at this point in time. What we now need to do is find the c. And remember what we noted earlier. When v equals u, h equals 0. So we'll sub that in. We have v squared plus c equals, well, I should say u squared plus c So my u squared plus c is going to be 2gr squared over r plus h, which means my c is 2gr squared over r plus h minus u squared. And given that's my c, I now have an expression to put in here, and I'll write that all the way on over here on the right hand side. That means my v squared plus my c, which is 2gr squared over r plus h minus u squared equals 2g. Oh, actually, I forgot to substitute that h, so we should fix that error first. So it's r plus 0, which is of course just r, right? Because remember, h is 0. So that's just r. So it's 2gr squared over r, which I can even simplify even further. Great. So that is just 2gr minus u squared. All right. Well, that saves us a little bit of work. That means we've got v squared plus 2gr minus u squared equals the thing on the right-hand side, which is 2gr squared over r plus h. That means our v squared will equal 2gr squared over r plus h minus 2gr plus u squared. And then a bit of simplification will get us there. So u squared plus 2gr squared minus 2gr times r plus h all over r plus h. And if you expand that, you'll get 2gr squared, which will cancel out with that, minus 2grh, which is u squared minus 2grh over r plus h. Just a little bit of simple algebra simplification work. And that is the answer we get, which hopefully matches the answer they wanted. V squared equals u squared minus 2gr. Well, okay, not quite exactly. I mean, they said 1 plus r over h. All right, so what we basically need to do then to get to what they want is very simple. A little bit of algebra manipulation. Let me just move that here. Whoops. And so this was finding C. So we're not done yet, but very close. This is finding C. We just need to go, okay, divide by h. U squared minus 2grh all over h. I now need to divide by h here. I now need to divide by h here. As we said before, when we divide a fraction's numerator by h, we're dividing the whole thing. So 2grh over h is just 2gr. The denominator is two terms, so it's really just, we can separate it out as r over h plus h over h, right? Which then means you've got u squared minus 2gr over 1 plus r over h. And that is what they wanted. And that's how you do that question. So, time to move on to the next question.